Our session today is about creating a simple recommendation system, and we will see how we can create one using the Python language. Before going into coding and the technical side of it, we need to understand what is a recommender system, why do we need one, and a couple of different types of recommender systems that there are, and how do they work. So recommender systems, as you might already know, even from layman's perspective, when we watch Netflix, we have or Amazon Prime, we have a lot of movie recommendation or serial recommendations pop in all the time. This movie recommendation or serial recommendation by Netflix or Amazon Prime are user specific. The movie recommendation that you are receiving are not the same recommendation that your friend is receiving. Now, how do they differ? They differ based on your viewing habits. The same goes for music recommendation from apps like Amazon Music or Apple Music or for instance Ghana.com, etc., etc. So they also have music recommendation engines that work in the similar fashion based on somebody's music choices of what kind of music they have heard previously or downloaded previously. The future recommendations are going to be determined. Okay, and same for Flipkart's or Amazon e-commerce product recommendations. So any e-commerce, any mature e-commerce site you go, based on your purchasing habit, you will see that matching recommendations or newer recommendations are coming in all the time. So there is it is always very, very user specific. It is different from you, different for your friends. Now it is based on individuals' purchase habits for e-commerce products or watching habits for Netflix or Amazon Prime, etc. Okay, so what is the data behind this movie recommendation or product recommendation that these sites are bringing up? It is based on your purchase habits, what kind of movies or what kind of music or what kind of product you have used previously, and what kind of movies and what kind of music or what kind of products you have provide ratings on or written reviews. So ratings, reviews, and purchase and viewing habits are the main sources of information for these sites to create a recommendation or personalized recommendation for each user on their site, on their product offerings. And why are recommendation engines important? Recommendation engines are important because when you go to Amazon, if the recommendation engines are not there, you have to literally search for products that you may like. And that is one thing from your perspective. So Amazon is helping you get those products that you may like more easily. Rather than you searching for them, it is producing it in front of you automatically. So that is one way of looking at it for the purchasers or from the consumer's point of view. Your purchasing experience is much more smoother, easier. Product search is much more easier, etc., etc. But from the product seller's point of view, from Amazon point of view, or the merchant who is selling on Amazon, the merchant who is selling those products on Amazon, from their point of view, it is extremely beneficial because sometimes what happens is that if the consumer is not easily able to find the related products or products of choice they might end up buying, they will not remember, or they will probably leave the e-commerce site without making that purchase. But if you throw those recommended products or recommended movies or recommended music, then you are increasing the chance of or probability of that customer buying those products from your site. Okay, so from the consumer's point of view, it is easier or smoother or more efficient experience of watching or music listening or product purchase. And from the sellers or merchants or e-commerce sites point of view, your sales increase exponentially through recommendation engines. Right, so that is the benefit of recommendation engines. And as I said, ratings, reviews, purchase, your views of movies, etc. These are the primary sources of data for recommendation engines. Now let's get into what are the two primary types of recommendation engines that there are. There are two types of recommendation engines that we can create, collaborative filtering and content-based filtering. There are other types of recommendation engine. However, we will limit ourselves to these two types of recommendation engines for the purpose of this session. Okay, so what is so we will focus on content-based filtering first. The content-based filtering recommendation engine first, which is, look at this diagram. There are two purchasers here. Okay, two different purchasers. Now this guy has purchased this t-shirt, this tie, and this jacket, and this person has purchased this t-shirt and this jacket. Okay, now look at this jacket. In your if you are the e-commerce supplier, let's say you are Amazon, you have this jacket and you have also this shirt, which is, or jacket, which is similar. Okay, in terms of product attributes of these two products, they are similar. So your system knows, your Amazon recommendation system knows that these two products are similar because a lot of their attributes are similar. So if this person is buying this product, and if this product is similar to this product which he has already purchased, then he might be interested in buying this product as well. Okay, so this is content-based filtering. So content-based filtering is recommendation of similar products, products similar to the ones they have already purchased. Now, what is collaborative filtering? The collaborative filtering is, we have said that this person has purchased these three items, and this two items are purchased by this person. Now look at this, these two items are common in the purchasing, right? So these two items are common. That means this person and this person are similar. They have similar purchasing habits. So it might be that this product also may be of interest to this person. So if these two persons are similar in their viewing habits or purchase habits, then the products purchased by another one person, which is not purchased by another person, may be of interest. So this product is purchased or recommended to this person also. Okay, so this is collaborative filtering. So products that are purchased by one of multiple similar users are recommended to other users as well. So that is collaborative filtering. So we now understand these two concepts. One is content-based filtering and one is collaborative filtering. These are two main types of recommendation methods. So to start with, so this code is about creating a simple recommendations system using Python, similar to what I was explaining on the functional terms as to what is a recommendation engine, and we will try to find out, okay, given a particular movie, how can we find out from my repository of movies and ratings by users as to which movies are the nearest to that particular movie. Okay, so our problem statement is, we will take a sample movie name, and from the repository of movies along with its user ratings, we will find out which are the movies which are nearest to it, with the purpose that we will recommend those movies to the person who or persons who have watched the original movie, the movie in my problem statement, the single movie in my problem statement. Okay, so that's my problem statement, and let's see how we can code the recommendation engine using Python. Alright, so the first thing we are going to do is that we are going to import a few libraries, NumPy, Pandas, because we are going to work with arrays, and we are going to work with series and data frame objects, so we need Pandas, and we also will do some visualizations in this particular code, and for that we need the matplotlib and the Seaborn library. So we import this, we also import warnings and issue this command to suppress any warning messages that come up and disturb the kind of flow of the program. Okay, so there are two data sets that we are going to work with, and we are going to import both these data sets. One is the ratings file and the second one is the movies file. So we import the ratings file first. So this is in my current folder, so we are not mentioning any folder structure. So ratings file is imported into a data frame. So the read CSV function from pandas library is going to import the source file into a data frame. So when we display the data frame, it's going to have this data. So what do we have in this ratings file? We have the user ID, we have the movie ID, we have the rating, and we have the timestamp. So basically in this file, or in this data frame, now we have about 105,000 records. So that's a lot of records. So and there are lots of movies for which the records are there, and for each movie there are going to be multiple records for multiple user IDs who have given ratings against those movies. Okay, so if there are there could be about 10,000 movies, and on an average if there are 10 users who have given ratings per movie, this is coming to about 105,000 rows or observations in our ratings file. All right, so there are going to be multiple movie ID and ratings for each of the users who have given the rating, and for each user ID also he or she may have given rating against multiple movies. Okay, so many to many relationship is possible between user ID and movie ID against rating in this file. The other file is the movies file. So this is basically the master file of movies. So it has, as I was saying, that there are about 10,000 movies, and these 10,000 movies are stored in the movies file. So the columns that we are going to have, or features that we have in this file, are movie ID, title, and genre. Okay, and the genres are kind of separated by the pipe symbol or vertical dash symbol. Okay, so what we are going to do is that we need both this data in one place. So we need to basically perform a join of this two files. So we have user ID, movie ID, ratings, and timestamp, and here in this case we have the movie ID, title, and genres. So in this file the movie ID is the unique key, because so one movie appear only once in this file, but in this particular file, in the ratings file, we have multiple occurrences of user IDs, because one user ID may have given ratings against multiple movies, which is the case here, you can see, and one movie may have been given rating by multiple users. So both user ID and movie ID may be repeating multiple times for each combination. Pandas merge function to merge this two or join. This operation of merge in pandas is a operation which is similar to an RDBMS table join. Okay, so the DF ratings and the DF movies data sets or data frames are being joined based on the movie ID. So what is happening is in result you are getting a superset of your total data. So in your ratings data set you had 105,339 number of rows. So in your merge data set also you will have 105,339 number of rows. For each of these 105,339 rows, what this merge function is going to do is it is going to join the rating data with the DF data. So what is the balance features that are coming from DF movies? The title and the genres. Okay, and they are being joined based on the movie ID. So the merge function is going through each of the records in DF ratings, and for each of the record based on movie ID, it is pulling the title and the genre from the DF movies dataset. So this is an important operation for pre-processing our data. So we need combined data of movies and ratings information. So that part is done, right? So now you see that the shape of movie data is 105,339, which is the number of rows that we have in the ratings file, and the shape is 6 columns. So additional to the features that were already present in the ratings file, we also have the title and genre. So that is why we have 6 columns now in the new data set, movie data, which is also a data frame. Right, so the next operation that we do is we want to do some analysis on this data set and find out, okay, what is the nature of the data that we have in this data set. So we do, in this case, we do a group by based on the title of the movie. So what this group by function is going to do is that for each unique value of title, now what are the each unique values of title is the movie names, and the movie names are repeating many number of times. Okay, on an average, how many unique titles are there? The unique number of unique titles are going to be 10329. So that is the number of movies in the movies, your initial movies file, right? So that many number of unique movie names are going to be there. So the group by based on title is going to pull in all the unique values in title. So that is 10329, if I am correct, remembering from the movies table or movies file that has come in. And after grouping it on the basis of title, so basically how many groups are we going to have by the group by command 10329, because there are 10329 unique titles in our data set right now. Okay, out of 105,339 number of rows in the current data set. Now that's not all. We want to see for each of those 10329 number of movies, for each of them, what is the average rating value. So in each of the groups, so that means for each of the titles, each of the movies, we are taking the ratings values. So let's say, for instance, Hellboy Seeds of Creation, this particular movie had 5 rows in the movie data frame. Okay, because 5 users or 5 viewers have given ratings for this particular movie. So this mean function is actually creating the mean of the ratings values on that title, and it is applying it here. Okay, so this particular command is going to give us the average movie ratings for each of the titles, right? So this is going to give us as to, okay, so these are the kind of ratings that we are talking of. Going a little further, we do the same thing. However, we do the same thing, exactly same expression as the above command. Going a little further, we sort these values. Which values? This value. So basically, this expression returns a series object. So this is the index of the series, and these are the values of the series. Okay. So in this series object, just take the values, the series values, because series have only one set of value. They have the index and one set of value. That is different from data frame, wherein the data frames have multiple columns. Series have only one column or one set of values. Okay, so it takes the values in this series object and it is organizing it on a descending manner. So ascending equals false with sort values function is going to organize this series object values in the descending manner. So when this expression prints the data that it has processed, it is showing the ones with the highest rating. So that means 5. So Being Human or 3 Ages or The Liberator, etc., they have all perfect 5 scores, and the lowest ones are here. So of course it cannot display all the 105,000 rows here. So it is giving this ... and displaying the bottom 5 records, which are like rating 0.5, etc. Okay, so this gives us a fair idea about what kind of rating we are talking about, and the data is nicely organized and so on. Going further, we take a count as to, we also need to have a kind of idea as to how many ratings each of these movies have received. So obviously not the same, not all titles have received the same number of ratings. So some movie may have received 1 or 2 ratings, and some movie would have received maybe 1000 or 100 of ratings. Okay, so we wanted to check as to how many values each of these movie titles have, or how many ratings each of these movie titles have received. So, and we do that by again issuing that group by function on ratings, and then in this instance, instead of mean, we issue a count function. We apply a count function on the resultant value of the group by function, and the count is going to be on the ratings values. Okay, now it returns that Pulp Fiction, the movie Pulp Fiction, has received 325 ratings. Forrest Gump has received 311 ratings. Shawshank received 308, but movies like Le Grand Restaurant received 1 rating, or League of Ordinary Gentlemen received 1, or Leap Year, etc. They have received 1 ratings each. Okay, so it actually establishes what I was mentioning, that some movies would have received 1 or 2 ratings, and some movies would have received ratings in the number of hundreds because of their popularity. Okay, so now what we are going to do is we are going to create a data frame with average ratings data per movie. Now, how do we do that? We are going to issue this pandas data frame function, and in the movie data, so movie data is our movie data. So this data frame we are talking about, this is our movie data frame, which is the merged version of our movies and ratings files. So 2 data frames are merged into the movie data. So movie data frame has all the data of movies and ratings in it. Okay, so we go back and see, on movie data we apply a group by function on title, on rating, and mean. So what it is going to do, and we also, okay, so before what it is going to do is we also insert a new field in the new data frame that we have created here. So the ratings mean count is a new data frame that we have created here, and that data frame has the return values of this expression. So it is going to have all the movie names and the ratings values, and their not the ratings values, actually the mean values. Okay, for each movie, because for each movie, because you are going to group by the movie data by title, so it is going to return 1 row for each movie or each title, and the value that it is going to have is the ratings mean. Okay, so when after this command is executed, you have these values. Okay, not the last column. The last column is inserted after that. So we have the title and the ratings values. Okay, and the ratings values are actually the mean of the, or the average of the, of all the ratings that this movie has received. Okay, so we have received that, and then going a little further, we also insert a field in which we have inserted the number of ratings that particular title has received. Okay, so again we go back to movie data, group by on title, take the rating, and take the count, and the return value, it goes to this new field of ratings mean count data frame, which is this one. So this field here is inserted on this. Okay, so we have a data frame now which has the movie titles, we have the average rating values, and we have the rating counts as well. Okay, so this gives us a fair idea about the data. It gives us the kind of visualization or kind of insight into what ratings are we talking about and what kind of counts are we talking about. So in case we have an anomaly, we can detect from here. Now a little bit more analysis. We have the rating counts, and we want to understand, and these are all part of any Python assignment, any machine learning or data science assignments you undertake, there are going to be a lot of analysis that you have to undertake or execute in terms of understanding your data. So one of the analysis that you perform during your exploratory data analysis to understand the data is understanding the distribution of your data, which is also called univariate analysis as part of exploratory data analysis. So in this particular instance, what we are trying to do is we are trying to understand the distribution of rating counts. So what is rating counts? The rating counts is coming from the previous data frame that we have created just now, which has all the movie titles and their average ratings and the number of ratings that they have received. Okay, so that's the data that we have created, and now we want to understand the distribution of rating counts. So that means that we want to understand what rating values have received by movies, how many number of times. Now this is not a rating count versus movie plotting. This is only the rating counts plotting to understand the distribution. Ratings between 0 to, let's say this is 10 or 7 or 8, something like that, they are bins. So we insert 50 bins. So that means that we segment this data available to us in 50 number of ranges, and for each of the range, and this particular bar reflects one range out of this 50 bins, one segment. And what this means is that this many number of ratings have been achieved by this many number of movies. Okay, so this is essentially the distribution of rating counts and not ratings. So I was going into the wrong direction. It's a distribution of rating counts and not ratings. So on the x-axis you have the rating counts values, and on the y-axis you have the number of movies that have received those many number of counts. So more than 7,000 number of movies have received rating counts of more than so in the rating counts of this bracket 0 to say 5 or 7 or something like that. Okay, so which is the value range here. If you look at the x-axis range, so that's the value here. So it's a distribution of rating counts. So that essentially tells us is that how many number of movies have received how many number of counts in each bracket. Okay, and that data is coming from your rating counts value here. The second one we try to do is what I was starting to mention for the first graph is the distribution of ratings values. So how do we do that? If you try to interpret this particular plot, what it means is that values, which is here, which is about 0.5, are received by about 100 movies. Value 1, rating 1 has been received by about 200 movies. Value 1.5 have been received by about 200 movies. Value 3 or rating 3 has been received by about 1300 or 400 number of movies, and these are the ones in between. Now why is it looking weird? I mean, we have some of the bars in between sticking out very long. However, there are other values in between, in between the long stacks, long bars, which are the skyscrapers. In between there are small buildings. Okay, so why are these skyscrapers sticking out here? The skyscrapers are sticking out because these are the whole numbers, or the factors of 0.5. So this is 1, this is 1.5, this is 2, this is 2.5, this is 3, this is 3.5. So when you are asked to rate a movie, you are not likely to give up 2.6 or 2.7, you are likely to give 2.5 or 3. So that is why the number of times the 3.5 value as rating was given is far higher than the ones in between. All right, so this is the distribution, and this is the reason why these skyscrapers are sticking out at these whole numbers, the 1s and 2s and 3s and 4s, and also in between 3.5 and 2.5, etc. Okay, so this gives us a fair idea about the distribution of the ratings value. So we get a distribution of the rating counts, and we get a distribution of the ratings values themselves as well. Now mind you, this ratings values that we have taken are not the individual ratings values, but for each of the titles it's the average ratings value. So it's this. So let's say, yeah, so for 71, the movie, let's say Till There Was You, for this particular movie, the average rating is 4. So that is what is plotted here, not individual 3 ratings that this movie has received. Okay, so it's in the distribution, this is featuring only once, and that is the average value. So these are I'm telling you this because these are also part of exploratory data analysis, and this is a useful information that you can get about the data. May not be the case that all the information are going to be directly contributing to your developing the recommendation system, and in our case it's a pretty naive recommendation, a simple recommendation system, but for understanding the data set and understanding the data and its patterns, it is these are important analysis. Okay, so we also create a joint plot between the ratings and rating counts. So essentially what we are trying to do here is that if we plot the ratings, average ratings of the movies on the x-axis and the rating counts along the y-axis, then how does it look like? Now it looks like this. Can you read the pattern? It has some kind of correlation between them. As the number of the average rating value goes higher and higher, the number of times they have been given ratings is going higher. Now why is that? Because movies with low ratings are not watched by many people, and thereby the number of times people have given them ratings are also low. Movies between 3 and 4 or towards 5 are watched by a lot of people because they are good movies. Okay, so if they are good movies and already attracting higher ratings, they are being watched by a lot of people, and thereby the number of times their ratings, they are getting their ratings by viewers are also getting higher. So there is a direct correlation between this. Okay, and this is done by a Seaborn joint plot. The characteristic of the joint plot is that one, it plots a scatter plot in between along the x-axis and y-axis. So you see the scatter plot, and from the scatter, which are the data points, the ratings and rating counts data points are plotted in this from each of the how many number of rows our data has, which is ratings mean count. We have about 10,000 number of data points. So this scatter plot contains 10,000 data points, okay, along ratings and rating counts. The other important characteristic of the joint plot is that the distribution that we have plotted here, which is the distribution of the rating counts and the distribution of the ratings, okay, the average ratings, these two along their axis are also plotted. So we actually got this one. So the ratings distribution, individual distribution, univariate distribution. So this is the bivariate scatter plot between ratings and rating counts, and this is the univariate distribution plot of ratings values, and this one is the univariate distribution plot for rating counts. Okay, so these two are essentially the ones that we have got separately, individually in the above two sections. Okay, so this is a Seaborn joint plot. Now we come to the last section of our getting into finding out similar movies to a given movie. Okay, so to recap, what is our problem statement? Our problem statement is that if we provide a movie name, say Forrest Gump, then my system should be able to pull out all the movies that are similar to Forrest Gump, and taking that output is important for us, and till that point we will do the coding for this recommendation system. After that, what happens is based on your functional system, how you display those similar movies to your users or viewers or purchasers, etc., is a different application altogether. So we will code up till finding out similar movies to a given movie. Okay, so let's see how we can do that. All right, now the main algorithm or the main logic behind finding similar movies is finding a similarity matrix, okay, or a correlation, right? We will use the correlation between ratings of a movie as a similarity matrix. All right, so we will find, based on an automatic correlation score of the data that our movie has to the data that our entire data set has. So taking the data of a particular movie, we should be able to find out similar movies from our overall data set. How do we do that? Let's see. We will use, okay, so let's look at the code one by one. Now we are going to first create a pivot table. Now you may have created pivot tables in Excel, okay, in Excel sheets. So essentially what it does is from raw data, it creates groupings based on indexes that are mentioned. Okay, so there are row-wise grouping, and there are columns and values that are mentioned under those groupings. So what we are going to do is we are going to take our merged data. So movie data, if you remember, what is the movie data? Movie data is our initial value, which is the merge or joint merge data of our movie data and ratings data. So movie data is a data frame which has user ID, movie ID, rating, timestamp, title, and genres. So this is our original data. It's a merged data, both rating information and movie information in one place. Okay, so that is my source, and we are going to create a pivot table similar to Excel. Now what is going to be our index for the pivot table? It's going to be user ID. So user ID is going to be our row index in the pivot table. So this is a pivot table that is created, and the row index are the user IDs. Now from our data, we know that there are about 666 unique user IDs. So from our movie data, it is pulling out the IDs of all these 666 user IDs. Okay, the column that we are going to have are the titles. So what this is going to create is that it's going to create a data frame where user ID is going to be the row index, and in the columns we have all the movie titles. And how many titles do we have? We have more than 10,000 movie titles. So we have 10,323 or 22 movie titles. So all those movie titles are created as one row in this data frame, which is my pivot table. Okay, so I'm explaining the parameters one by one. So index user ID are the rows in the pivot table. Columns are the titles, movie titles here. Okay, so if you can follow my mouse cursor. And the values, what are the values in the pivot table? The values in the pivot table are these, which are the ratings. So the ratings are for this particular, let's take a value, let's say take this value. Okay, so this particular user ID 666 has given a rating of 2.5 for this movie Round Midnight, or he or she has also given a rating of 2.0 for Days of Summer. Stingy fellow, I think, doesn't give good feedbacks. But on the other hand, this user ID 666, this guy has given a rating of 5 for this existence. Okay, right? So this is the data that we have created now. It's a pivot table, which is a pandas feature. Okay, how is it a pandas feature? Because movie data is a data frame, and this is a data frame function. Clear? This data, this is what we have created. So each title will be a column, and in that column, against all the user IDs, it'll have the ratings. Now, what is this NaNs? I mean, this is full of NaNs. NaNs are missing values. Okay, so why do we have missing values here? The missing values are there because this guy, user ID 3, has not given any rating for this movie called Hellboy. Okay, and that is the case for most of these users. Okay, so each user would have given rating to, let's say, 3 or 4, or in some cases only 1. I have watched a lot of movies, or maybe I don't watch movies at all, and I have given only 1 rating. Okay, so there's going to be those cases, and there's going to be those cases where an user may have given rating to, say for instance, this person 668, user number 668, has given rating to a lot of movies. So this guy watches a lot of movies, so he has given a rating against Around Midnight, and then Days of Summer, and Justice for All, and 10, and Rec Square, Rec Cube, etc, etc. So this person has given a lot of ratings. So you have both kind of scenarios. So this is my starting position. We have created this pivot table, which is essentially a data frame here. Now we select a movie which is Forrest Gump. Okay, very famous movie. A lot of you may have watched this movie also on Netflix or whatever. And we see what ratings it has received. Okay, so it has received, I am pulling out the data from this data frame called user movie rating, which we have created here. So this is the pivot table. So basically this pivot table data frame that we have created here, and I am pulling out the column that belongs to Forrest Gump. Okay, so one of this column is Forrest Gump. It is not displayed because there are a lot of rows. How many number of rows? How many number of columns? 10,000 columns, because there are those many number of movie titles, and it is displaying for user ID is 1 to 668. What are the ratings it has received? So it has actually received a lot of ratings. Okay, the next thing we are going to do is, from this movie rating data frame, I am going to pull out all the rows which are greater than 3. Now that is giving me this. So these are all the rows where Forrest Gump has received ratings greater than 3, which is fine, which is clear. And also we create a series object with the user ratings for Forrest Gump. So previously we were displaying it, but this time I am creating a series object with this expression, which is basically this expression, but we are capturing this value in terms of a series object. So Forrest Gump rating is a series object, and the series object has the user IDs as the series index, and the values which are the ratings. Now the next thing we are going to do is, this is our final step. We are going to use a core width, the core width function with the pivot table that we have created, the core width function, and we are going to pass a series object. This series object contains all the movie ratings of Forrest Gump. Okay, so you remember we have created this series object which contains for all the users the ratings that Forrest Gump has received. So we are going to use the data frame, our pivot table, we are going to use the core with. Core with stands for correlation with, and we are going to pass the series object which contains the ratings of Forrest Gump. What this is going to return is a number of columns, okay, as a data frame which will contain the correlation matrix of all the movies against Forrest Gump, which is the output of the core with or correlation with function of pandas or pandas data frame object. Okay, now it returns a value. It returns a value against all the movies, and that value is a correlation value or degree of correlation between that movie, between each of the movies in the data frame, our pivot table, which has columns against all the movies correlated or matched against the Forrest Gump ratings. So the Burbs movie has a correlation value of 0.05, which is minuscule. So it kind of interprets as, okay, I have a 5% correlation with Forrest Gump. This one kind of turns out to be, I have a 14% correlation with Forrest Gump. But this movie 10, or let's say Rec Square 2009, has a correlation of almost 83% or almost 84% with Forrest Gump. This is a very close match to Forrest Gump in terms of the ratings. Okay, so based on this correlation value that are returned by the core with function, we now know for each of the movies what is the degree of correlation that they have with Forrest Gump, right? And that is what we have received here. So essentially the next step here, we have created a data frame like this, in which we at one side in the index we have all the movie titles, and in the column we have the correlation value. The column correlation is created. Okay, so and it is coming from this series object, and we just want to drop any any row with null value and print this series object. Okay, so these are essentially the series objects. So we have got the correlation value between each of the other movies and Forrest Gump. Okay, now higher the correlation, the greater the similarity between Forrest Gump and the other movie. Okay, so what we need to do is basically we need to sort this data frame based on this correlation values, and I'm sure there are going to be some movies which have a very strong correlation with Forrest Gump, and thereby returning a correlation coefficient or correlation value of 1.0. Okay, so these are very strong matches with Forrest Gump in terms of correlation value. So now we've got the result of our recommendation engine. Okay, so these are the movies that we should recommend to an user who is watching Forrest Gump. Okay, so this is the output that we have. Now there are some further analysis that we carry out, which is to find out the total number of ratings for each of the titles. So from the core with function we have got the correlation values, but it interests us to see that, okay, what are the number of ratings that each of these movies have received, and combine it with the correlation value that they have. So we see that there are this information is presented. So the company of Maine has received 9 ratings, and Turbulence gets 9 ratings, etc., etc. Okay, so this is some further analysis, but our recommendation result is basically this, and these are the movies that we should recommend to users who are watching Forrest Gump. So this is how you can create a recommendation engine in a very simple fashion. Now there are other complicated ways or more sophisticated or complex ways of creating a recommendation engine using machine learning algorithm, mostly using classification algorithm, etc., and in some cases clustering algorithm possibly. But we wanted to show you an example of a simple recommendation engine as to, given a product, from the ratings and reviews, information, how can you pull similar movies or similar products for your recommendation engine. Okay, although this is simple, for a lot of practical scenarios, a lot of simple practical scenarios, simple to medium complexity practical scenarios, this kind of methods are absolutely fine. Thanks for watching this workshop on creating a simple recommendation system, and we will see you in the next workshop. Thank you.